Welcome everyone to the circles portion of geometry. So let us start one of the important things that we should know, chord. Chord is basically a line joining any 2 points on the circumference of the circle. So if you are considering 2 points here, right, joining those 2 points, what will be the line segment that we'll be getting? We call it as chord. So if you are considering PQ is one chord, we can say. Okay. And if you are drawing the chords, different chords of lengths, different lengths in a circle, can we say AB is also a chord we will be having or not? And AB is nothing but diameter, already I have mentioned. So what we can say is longest chord in a circle, longest chord in a circle is nothing but its diameter. Okay. This is what we have studied even in school days also, right? Longest chord in a circle is its diameter. And there are some important points that we should know about chord. If you are drawing a chord like this one, joining some points like R and S, and if you are dropping a perpendicular from the center of the circle to that particular chord, what we can say is that will be bisected. That means if it is touching at cutting this one at some T, what we can say is RT will be equivalent to ST. So longest chord in, if you are looking at the perpendicular drawn from the center of a circle to a chord, bisects it. So it divides that into 2 equal parts. And one more point that we can say is RS is at some distance like X if you are considering. And if I have P and Q is also having its perpendicular distance from the center as some X. Already we have seen PQ is also a chord. If they are of equal distance from the center, what we can say is PQ's length will be equivalent to RS. Or in other words, what we can say is 2 chords, if they are equal length, 2 chords are of equal length, they will be always equidistant from the center of the circle. So 2 chords of equal length are always equidistant from the center of the circle, always equidistant from the center of the circle. And in that way, if you just recapitulate based on points based on the chord, what we can say is longest chord in a chord is first of all any line joining any 2 points on the circumference of the circle, and longest chord is basically diameter, and we can say 2 chords, if they are of equal length, they will be equidistant from the center of the circle. And one more small point that we can say is if we drop a perpendicular from the center of a circle to a chord, it will be bisected. So in that way, these are the important points that one should know about chord. And let us focus on the next aspect, that is tangent. Line that touches the circle at only one point, from a line that touches the circle from an external point is basically tangent, we can say. So if you are looking at, if I consider an external point like X here, right, the line that touches the circle at only one point, like this is what is touching at Y, then we can say XY is a tangent. The line that touches the circle at only one point, will be considering it as tangent. And if you are observing from an external points, how many tangents can be drawn to a circle means X and Y we have observed as one part, as one tangent. And if you are considering in that way, we can say that will be touching the circle at one more point like Z. So what we can say is XZ is one more tangent. So tangent is basically the external, the line that touches the circle at only one point from an external point, the vertex that we are, external point that we are considering. XY and XZ are tangents, we can say in this particular case. And if we are considering one more important aspect here, as they are drawn from the same external point X, we can say they will be always of equal length. XY should be equivalent to XZ, we can say. And one small point that we should know about tangent is tangent and radius. This is what is basically radius, we can say, right? Radius and tangent, they will always meet at 90 degrees angle at the point of contact. Or in other words, what I can say is OYX, angle OYX will be equivalent to 90 degrees. OYX will be 90 degrees in that particular, what we can say, tangent or quadrilateral portion in that way. So tangent is one more aspect that we should know. Let us focus on some more aspects based on circles. Yeah. One more concept that we can associate with circles is secant, right? Tangent is a line that touches the circle at only one point, and if you are considering a secant, the line that cuts the circle in two parts on its circumference is basically known as secant. Suppose if you are drawing a line that cuts the circle at 2 points like P and Q in this way, then we call PQ as secant. And if you are observing carefully, from this we can have any number of secants can be drawn. So if you are considering this starting point as some A and APQ is one secant, I can say, like if you are considering this is cutting the circle at some points like R and S, ARS is one more secant we can say. So in that way we can have any number of secants can be drawn from an external point to a circle. And if we have two secants particularly are drawn to a circle, then we have a small theorem saying that AP into AQ, if you are considering APQ as a secant, AP into AQ should be equal to AR into AS. Okay. And instead of secants, two secants, if we have a secant like APQ is there and one more line, that one if it is drawn this way, that is tangent, AT is a tangent, then what we can say is AP into AQ should be equivalent to AT square, right? So these are the points that we can associate with secant. And let us focus on one more small aspect, that is arc of a circle. Arc of a circle, right? Secant is basically the line that cuts the circle at 2 points, and if you are looking at arc, the portion on the circumference of the circle is basically known as arc of the circle. So if you are looking at these points are considered as something like B and C. Okay. Suppose this is D. What I can say is BDC is arc of the circle. BDC is arc of the circle. Okay. And for a circle always we will be having 2 points that we can say about arc. BDC is known as, because it is a small portion only that we are considering, is known as minor arc. Okay. And if you are considering a point like E here, BEC is one more arc of the circle we can say, and that BEC is known as major arc. Okay. But in general arc refers to minor arc only. And based on arc we have a small theorem, we will look at that one based on a small diagram, based on a small circle drawn for this one. Yeah. Let us have a small circle in this way. As mentioned earlier, like if these are the points that we are considering like A and B, this as some C, ACB is minor arc we can say, that is what we already considered. Suppose if O is the center of the circle that we have, what we can say is angle made by this arc at the center, right? If you are considering this one, AOB is some angle we will be having. Whatever be the angle made by this arc at the center is twice the angle made by it in the remaining portion. Suppose in the remaining portion if you are considering a point like P here, what I can say is if we have this angle at P of by this angle, this arc AB is some alpha, what we can say is at center it should be 2 alpha. So angle made by arc at the center is twice the angle that it will be made in the remaining portion, twice the angle made in the remaining portion, made in the remaining part of the circle. So that way we can say this is one of the important theorems that we will be using for answering the questions based on circles, remaining part of the circle, right? Let us look at one more small aspect of circles, that is segment. And for looking at segment, let us have again one more small figure, one more small circle. Let us have that one. Yeah. The circle is in this way with center O. Okay. And what we are looking is segment. Segment is basically the portion of the circle separated by a chord, right? This is what is the chord that we are considering. As we have 2 different parts for arcs like minor arc and major arc, here also we have 2 different parts. One is minor segment, the other portion is major segment. So the one that is covering the lesser portion is basically known as minor segment, and occupying the major portion, it is known as more area, it is called as major segment. And we have a small theorem based on segments. What we can say is angles in the same segment are equal. That means if they are extended from the same chord, they are always equal. So if we just draw these angles in this way, if this angle is some alpha at point C, ACB if it is alpha, I can say ADB also will be alpha. So angles in the same segment are equal. This is also one of the important points that we should know about circles. Angles in the same segment are equal, and this is more often we use for solving the problems, right? So till now, if you are looking at, our focus is on understanding what is chord, what is tangent, and then what is secant, what is arc, what is segment, in that way. Let us look at one more small important theorem that we should know about circles, known as alternate segment theorem. Yeah, alternate segment theorem. This is one of the important theorems that we'll be regularly using based on the problems based on circles. So if you are looking at, the theorem says angle made by a chord and a tangent at the point of contact of that with the circle. So this is what is point of contact of the tangent with the circle. Angle made by the chord and the tangent at the point of contact is equal to angle in the alternate segment. This is one segment of the circle we know. So this alternate to that one is this one. So whatever be the angle we have here, the same angle will be having here also. That means if we are considering this as alpha, we can say the measure of this angle also will be alpha. In the same way, if you are considering from Q, if you are considering a tangent is drawn, let's say this makes an angle of beta with the chord BC. In that case, what we can say is, as BQ is a tangent and BC is a chord, we have angle made by the chord and the tangent at the point of contact should be equal to angle in the alternate segment. So this is one segment of the circle, alternate segment is this one. So what we can say is this is also equivalent to beta. So that is what is basically alternate segment theorem. Angle made by a chord and a tangent at the point of contact is equal to angle in the alternate segment. So if this is alpha, this needs to be alpha. In the same way, if this angle is beta, this needs to be beta. So this is one of the important theorems that we'll be using for solving the problems based on circles. Yeah. Let us focus on one more aspect of circles, that is number of common tangents that can be drawn to two circles. If we observe in the first figure here, right, we have one circle is lying inside the other circle, and if we draw a tangent to this inner circle, it automatically becomes secant to the other circle. So can we have any number of common tangents possible here? Means no. So number of common tangents will become 0 in this case. Okay, and if we are observing, that means when one circle lies inside the other circle, we can say then there cannot be any common tangent to both the circles is possible. And if we are looking at figure 2 here, we have one circle is lying inside the, touching the other circle internally in this way, and we can have a small, we can have a tangent in this way that will be touching the smaller circle or inner circle as well as the outer circle in that way. So when we have one circle is lying, touching the other circle internally in this way, how many common tangents can be drawn? Means one tangent we can say. And if we have two circles which are intersecting in this way, what we can say is we can have two common tangents in this way, right? So if it is figure 3, if you are looking at how many common tangents will be having, means two common tangents are possible. And if we have two circles touching each other as shown in this figure 4, how many common tangents will be having possible? Means we can say two common tangents which are onto the same side of the same circle, both the circles, they are known as direct common tangents, and this is in between the two circles which is called as transverse common tangent. How many common tangents are possible? Means 3 common tangents we can say, and more. And the last case, if you are looking at one, the two circles are non-intersecting, nor touching each other, nor lying inside the other in that way, then we will be having how many common tangents possible? Means 2 direct common tangents are possible in this way, and 2 transverse common tangents are possible in this way. So in figure 5, how many common tangents will be having? Means 4 common tangents. And one more important aspect that we should know about in number of common tangents to circles is we should focus on the distance between the centers of the circles as well as their radii of the circle. In this case, if you are looking at, anyway here we are not having any common tangent possible, but if you are looking at here, the distance between the centers, if this is the center of the smaller circle and this is the center of the bigger circle, what I can say is this is what is the radius of the smaller circle and this is what is the radius of the bigger circle. So what I can say is the distance between them is nothing but equal to difference between the radii of the circles we will be having. So in this case, distance is equivalent to mod r1 minus r2 we can say. And in this case, if you are observing distance between the centers, if this is the center of the circle, this is the center of the circle, this is what is radius of the first circle, this is what is the radius of the second circle. What we can definitely say is distance between the centers is much straightforward path than compared to these two things. So that is the reason distance between the centers will be less than sum of the radii of the two circles we can say. And in this case, if you are observing distance between the centers is equivalent to sum of the radii of the circle. So when we have three common tangents possible to a circle, possible to two circles, what we can say is distance between the centers will be equivalent to r1 plus r2. And in the last case, what we can say is if this is r1 and this is r2, distance between the centers is much greater than that. So what we can say, when we have four common tangents possible to two circles, distance between the centers will be more than r1 plus r2. And one small point that we can extend here is, in this figure we observed that distance is less than r1 plus r2. Not only here, in any of the previous two cases also, distance between the centers will be less than sum of the radii of the two circles. So in that way, we can have important points based on number of common tangents. And one more aspect that we have to focus here is, as mentioned, these are drawn to the same side of both the circles. They are known as direct common tangents and this is known as transverse common tangent. And if you are looking at the length of direct common tangent, it will be equal to distance square, whatever be the distance between the centers of the circles we have, d square minus r1 minus r2 whole square. Whatever be the radii that we have for both the circles, take the difference of that one, square that one, and from that, that should be subtracted from d square. That will be giving us length of direct common tangent. And if you are looking at length of transverse common tangent, it is equal to distance square, distance between the centers, that is d square, minus sum of the radii whole square, r1 plus r2 whole square. So this is what is the important formula that we have to keep in mind for calculating lengths of direct common tangent and transverse common tangent. So with this one, we have covered most of the important points based on circles, right? We started from what is a circle, like set of fixed points which lie at a fixed distance from the fixed point is basically known as circle. From there to length of direct common tangent and length of transverse common tangent. Now we'll be focusing on some examples based on circles. Let's look at a small example based on circles. The problem is in this way. In the given figure, O is the center of the circle and the angle OAC is 60 degrees and angle OBC is 70 degrees. How much is, or find angle AOB is the question. O is the center of the circle we have. So if you are just looking at OAC is mentioned as 60 degrees. Can we say OA is the radius of the circle? And if you are observing OC is also radius of the circle, in that case can I say OAC is a triangle having two of its sides as equal. OA is equivalent to OC. In that case, as two sides are equal, we can say angles opposite to them are also equal. So angle opposite to OA will be C, OC will be A. So these two are 60 degrees we can say. As sum of the angles of a triangle is 180 degrees, the balance 60 degrees should be present here, right? In the same way, if you are looking at the other triangle, OBC is mentioned as 70 degrees. We have OB as the radius, OC also is the radius of the circle. In that case, can we say as OB and OC should be equal, angles opposite to them also should be equal. So OBC, if it is 70 degrees, opposite to that OBC also should be 70 degrees. As sum of the angles of a triangle is 180 degrees, we have 70 plus 70, already 140 is present here. So the balance 40 degrees should be present here. So in that case, we can say angle BOC is 40 degrees, AOC is 60 degrees. The question is asking for how much is angle AOB. So what we can say is angle AOB is sum of these two only or not. So in that case, can we say it is 60 plus 40, 100 degrees. So angle AOB should be equivalent to 100 degrees we can say.